Prepare to have your mind blown. Earth's crust is literally on the move, and we're just now accurately measuring its monumental shift. This isn't a theory from ancient history. It's a living, breathing geologic phenomenon happening right now in August 2025. From the smallest shifts beneath your feet to the vast tectonic rearrangements beneath entire continents, the Earth's surface is not as stable as we once thought. For centuries, we've understood that the Earth's crust moves, shifting ever so slowly through the process of plate tectonics. But recently, scientists have discovered something more startling and profound. Our planet's crust is undergoing a larger, more intricate shift than we ever imagined. It's not just a slow dance of tectonic plates. It's an entirely new kind of movement, one that's altering our geologic position and the very nature of the world beneath us. In this video, we are going to uncover the incredible implications of this evolving shift in the Earth's crust. We'll explore what it means for everything we thought we knew about Earth's geological position, how scientists measure these subtle changes, and why this discovery could change our understanding of Earth's dynamic nature. Imagine the ground beneath your feet isn't quite where it used to be. It's a strange thought, isn't it? The surface of the Earth, what we feel as solid ground, may seem immovable, unchanging, a foundation we can rely on. Yet it's anything but static. The Earth's crust is in constant motion. But recently, there's been a significant shift, one that scientists are only just beginning to fully measure. The movement we're talking about isn't just plate tectonics, the slow-moving dance of massive plates that have shaped Earth's continents for millions of years. Instead, it's a broader, more expansive phenomenon, a crustal shift that involves subtle, large-scale movements of the Earth's outer shell. This shift is occurring in ways we haven't fully understood until now. Plate tectonics, the theory that Earth's lithosphere is divided into large plates that float on the semi-fluid asthenosphere beneath them, has long been accepted as the driving force behind earthquakes, volcanic activity, and continental drift. But this new shift goes beyond traditional plate movement. It involves a complex series of smaller adjustments, slow but steady shifts in the Earth's crust that have been happening over millennia, but are now detectable with unprecedented accuracy. Scientists are using advanced geophysical techniques to measure this shift, methods that were not available just a few decades ago. They've discovered that the Earth's crust is not simply shifting at a rate defined by plate boundaries, but is undergoing subtle deformations across larger areas. What we're witnessing is a new kind of geological movement, one that goes beyond simple tectonic plate interactions. This movement is happening on a global scale, and it's happening right now. Tracking the movement of Earth's crust has always been a challenge for scientists. For years, we could only observe the large movements of tectonic plates through indirect methods, mapping earthquakes, volcanic activity, and studying continental drift. However, the scale of this new shift requires a new approach. Thanks to modern advancements in satellite technology, GPS systems, and seismology, scientists now have the tools to accurately measure and track the crust's movement with incredible precision. One of the most significant breakthroughs in measuring crustal movement has come from the development of Global Positioning System, GPS, technology. GPS satellites, originally used for navigation, now provide scientists with highly accurate data on the location of specific points on the Earth's surface. By comparing these points over time, scientists can detect even the most minute shifts in the Earth's crust. This technology has allowed us to measure the ongoing movement of land masses with millimeter-level accuracy. Additionally, seismic data has improved significantly. Traditional seismometers measure the movements of seismic waves caused by earthquakes, but they also detect long-term shifts in the Earth's crust. These devices are now sensitive enough to track movements that are too slow to cause earthquakes, but still have a significant impact on Earth's surface. By combining data from GPS, seismometers, and other sensors, scientists can create detailed models of the Earth's shifting crust. These models help us visualize the movements happening beneath the surface, revealing how Earth's crust is adjusting over time and how those adjustments may impact human societies and natural systems. The scope of this crustal shift is staggering. While the movement may seem imperceptible on a day-to-day basis, over time, these shifts can have profound effects on the landscape, climate, and even the way we live. Earth's crust doesn't just move uniformly. Some regions experience more dramatic shifts, while others remain relatively stable. These uneven movements can result in a variety of impacts, from shifting coastlines to altered earthquake risks. In coastal areas, even small shifts in the Earth's crust can lead to rising or falling sea levels, causing long-term changes to coastal ecosystems and communities. In places where the crust is being compressed, such as at convergent plate boundaries, the risk of volcanic eruptions and large-scale earthquakes can increase. Similarly, regions undergoing extension, where the crust is being pulled apart, could see the creation of new fault lines, further increasing seismic risks. Perhaps one of the most dramatic consequences of these shifts is the effect they have on mountain ranges, valleys, and plateaus. Over millions of years, the Earth's crust has created some of the world's most iconic landscapes. However, these shifts are continuing to shape those landscapes, often in ways that are difficult to predict. The Grand Canyon, for example, continues to evolve, shaped by both erosion and subtle shifts in the Earth's crust. Similarly, the Himalayas, one of the youngest and most geologically active mountain ranges, continue to rise due to the ongoing collision of the Indian and Eurasian plates. On a more immediate level, these shifts could lead to increased geological activity in areas that were once thought to be stable. Cities built near fault lines or on top of ancient fault zones could face increased risks as previously dormant geological forces stir beneath the surface. While the current crustal shift may seem like a subtle change, it has vast implications for the future of the planet. One of the most pressing concerns is the potential for increased earthquake activity. As the Earth's crust shifts, stress builds along fault lines, making it more likely that earthquakes will occur. In fact, in some regions, these slow movements may be responsible for the gradual increase in seismic activity. Another concern is the role this shifting crust may play in climate change. The Earth's surface influences everything from ocean currents to atmospheric patterns. As the crust shifts, it can alter the flow of ocean currents, which play a critical role in regulating global temperatures. Changes in land elevation and ocean depth could also influence the distribution of heat on the planet's surface, potentially exacerbating or mitigating the effects of climate change. Additionally, the shifting crust could play a role in the release of greenhouse gases, such as carbon dioxide and methane, from the Earth's interior. In areas where the crust is being pulled apart, the release of gases trapped in the Earth's mantle could contribute to atmospheric changes. While this is a natural process, the increasing rate of crustal movement could accelerate these releases, further influencing global warming. The study of the Earth's shifting crust is still in its early stages, but the implications of this new discovery are vast. For decades, scientists have studied the movement of tectonic plates, but the more subtle, gradual shifts in the Earth's crust were largely overlooked. Now, with advanced technology, scientists can track these shifts with unprecedented accuracy, uncovering details about the Earth's dynamic systems that were once hidden. This new understanding of Earth's crust has led to breakthroughs in our understanding of seismic hazards, as well as the potential long-term effects of climate change. It's a reminder that Earth is not a static, unchanging entity. Instead, it's a constantly evolving system shaped by forces deep within its core. By studying the shift in the Earth's crust, we are beginning to realize that we are only scratching the surface of what's happening beneath our feet. The implications for our cities, our environment, and our understanding of Earth's history are profound, and as we continue to monitor these shifts, we may uncover even more surprising revelations. As our understanding of the Earth's shifting crust deepens, it's clear that we need to adapt our approach to urban planning, disaster preparedness, and environmental management. Cities built near fault lines or on unstable ground may need to undergo major reassessments of their infrastructure to withstand the growing risks associated with these gradual shifts. Building more resilient infrastructure will be essential. Advances in engineering and construction methods that account for slow, steady movements of the ground, rather than just sudden earthquakes, will be crucial for mitigating risks. Urban planning should integrate long-term geological shifts into the equation, considering how infrastructure will adapt as the ground beneath shifts and settles over time. We also need to focus on global monitoring systems. Advances in GPS technology, seismic sensors, and satellite imaging have made it easier to detect these slow movements, but the data must be continuously monitored to identify potential hazards early. Governments and scientists need to collaborate more closely to ensure that the data is used effectively to protect vulnerable populations. As we've explored today, Earth's crust is far from static. From plate tectonics to subtle large-scale shifts, our planet's surface is in constant motion. While we've always understood that geological change is slow, the scale and speed of recent shifts have brought new urgency to the way we study and prepare for these movements. The implications of the Earth's shifting crust are profound. From rising earthquake risks to changes in the climate, the subtle adjustments happening beneath our feet are reshaping the planet in ways we are just beginning to understand. By studying these movements, we can better prepare for the challenges ahead and gain a deeper appreciation for the dynamic nature of the Earth. The Earth's crust may be shifting, but it is not just a natural event. It is a reminder that our planet is a living, breathing entity, constantly evolving and adjusting in ways we've only just begun to measure.